Fasteners can be manufactured by a number of different methods, and all of these have advantages and disadvantages, both from a technical and product perspective, but also from a commercial one. Having a good understanding of fastener production methods will help you to understand what you are competing against, as well as helping to make customers aware of these advantages and disadvantages. Hot forging is performed at really high temperatures. The increased temperatures helps to avoid strain and hardening, as well as lowers the stress flow and amount of energy needed to deform and shape metals. Heating causes the metal to become more ductile. When the pressure of the dies squeezes the hot metal, the structure transforms into a more refined grain that results in increased yield strength and ductility. The advantage of hot forging is increased ductility for more complex parts and allows more design options. In our case, it's ideal for very large dimensions. However, it adds additional cost for heat treatment, less precise dimensional tolerances, limited strength, and risk of damaging some materials. It is also labor-intensive, slow and expensive, meaning that it's usually only used for larger diameter parts where volumes are lower. Machining is a prototyping and manufacturing process that creates the desired shape by removing unwanted material from a larger piece of steel. This manufacturing method makes it possible to produce complex designs in different materials and sizes. It's ideal for sample production when small batches are required. However, it comes with a high cost since the material is removed. It's not suitable for larger volumes as it can be time-consuming and labor-intensive, and it's not possible to improve the material properties such as strength and ductility, as the material is not being changed in any way. Cold forging is a metal shaping and manufacturing process in which wire or bar stock is inserted into a die and squeezed into a second closed die. Cold forging is an efficient and economical metal deforming process for production of high volumes of parts at low cost. Unlike hot forging, cold forging shapes and deforms bar stock at room temperature using localized compressive force into a desired shape. Depending on the requirements of the part's design, the workpiece may pass through multiple dies or be struck several times in succession to achieve the proper shape. Cold forging consists of deforming a metal material at room temperature by applying very high pressure. From a larger wire coil, the wire needs to be drawn to obtain the correct thickness and strength. Then the wire will be cut into smaller pins. The pins are then placed in a die and then compressed by the action of a press until it fits into the desired shape. Depending on the geometric complexity of the component, several operations may be required gradually to deform the metal. Cold forging is a simple process where the workpiece is placed directly into the forging machine to instantly produce a finished part. Modern cold forming machines provide from 1 to 7 die stations, opposite a number of punches mounted into a slide. The wire is fed into the forging machine, and when the metal is compressed within the die, it is important to introduce just the right amount of material, often within plus or minus 1% or even less. Too little material won't fill the die, making a bad part. Too much material can result in a malformed part or produce flash that needs to be removed. There is a limit how much you can deform the material with a single punch, which is why the hammer may have to be dropped several times in succession to produce the exact contour and shape. Thread rolling is a metal forging process that forms thread into the mirror image of a roller die. The process is different from metal cutting, grinding and chasing because it does not remove any metal from the workpiece. Instead, thread rolling uses hardened steel dies to displace and mold ductile metals. The high-pressure process physically changes the properties of the rolled material parts to make the base part and the threads harder and stronger. Thread rolling has several advantages that traditional thread cutting processes lack. One key advantage is the strengthening force of the pressure, instead of cutting through the grain of the part's microstructure and weakening the workpiece in itself. Thread rolling realigns the grains while leaving them largely intact. This leads to many advantages, such as making the base part and the threads stronger, as well as high thread tolerances and thread surface, with a high hardness that reduces the risk of galling, which is a common challenge in many other stainless steel fasteners. The internal structure of the metal is organized in fibers. Cold forging allows control of the orientation of these fibers and makes it possible to obtain very high mechanical strength characteristics. As strength increases, the hardness of the material and ductility generally decreases. This is where Bumax manufacturing expertise and material knowledge is used to maximize both strength and ductility and achieve that optimal balance. Unlike bar machining, the fibers are not cut. As a result, cold forged parts benefit from optimal fatigue life, allowing them to be used in the most critical applications.